All right. I am presenting SYCL of interoperability with DirectX and Vulkan via Bindless images. Disclaimer is experimentation, so it's subject to change. We presented last year about Bindless images, so if you want to find more detail about that, go to these two links or just Google Bindless images and you'll find it. I will be going in quick overview of Bindless images and a catch up of new features, the status of importing from Vulkan and DirectX 12 into SYCL, exporting SYCL into Vulkan DirectX 12, exporting Vulkan DirectX 12 semaphores into SYCL and then exporting those, and then some problems encountered and interop as separate extension and some Q&A. Motivation Bindless images, SYCL 2020 images having too many limitations. The DPC++ implementation did not use texture hardware efficiently and was in fact manually emulating sampling. Needed to request access to accessors, the number of images, need no compile time, no control over how the image is stored on the device, the layouts, encodings, or its USM, no more advanced image types such as maps or cube maps, and no interop with graphics APIs. So Bindless images allows you to separate the image memory and the actual image object. You can use device optimized layouts, USM allocation from SYCL, or of course import in memory, and as well as adding Y wrappers. Images are stored as opaque handles, which most of the time they're just integers. No accessors required, and you can have any number of images at one time. You can have them all in the same way. You just need to access them appropriately. We have allowed flexible copy functions and flexible on-device access, many different options for copying and reinterpreting image data, as well as additional image types such as maps, cube maps, image arrays, and sampled image arrays. New features since IWOCL 24 is the explicit image access functions listed there, sampled image arrays, extended image copies, device image arrays, and more. USM host image memory and copies. Vulkan map interop. Some limited 3-channel image support. It's currently in level 0 only, and gather image to get the values used for linear interpolation. On backend support, CUDA backend supports pretty much everything in the spec, with the only caveat being 3-channel images only supported on level 0 backend. There's partial support in using indoor devices via level 0. So 1, 2, 3D images sampling, some USM images, image arrays, and of course 3-channel images. And the HIP backend, we have some basic support, 1, 2, and 3D images and sampling. We got, as seen before with the Blender presentation, Blender uses to get that working Bindless images, or Bindless images extension was used. Intro changes have been pushed to Blender. I don't believe it has been fully upstreamed yet. It works on CUDA, level 0, and HIP. We've collaborated together to optimize as much as possible. Blender does not currently use interop features, just wanted to mention, although we will be looking to see if that could help in any way. As previously covered in more detail in the previous presentation. Now on importing Vulkan and DirectX 12 memory into SYCL. No copies. Otherwise, without interop, you would have to copy back to the host and copy back. Easier leveraging of existing DirectX 12 libraries in SYCL and vice versa. And we have sort of designed our API to be generic and applicable to other external APIs where we want to add them. So without SYCL interop, you would have to, of course, initially request a device allocation, do your Vulkan processing on the memory, and then if you wanted to use that in SYCL, you would have to transfer it back and transfer it back to the device on the SYCL context, then do your processing and transfer the results back. With our interop feature, that you get rid of those extra 2 steps, and you just can use the exact same memory allocation within Vulkan and within Vulkan DirectX 12 and SYCL. This is the sort of the basic process of important memory. First, you create the memory objects in Vulkan and DirectX 12 and make them exportable in each of them. They are both imported into the SYCL context via import external memory. And then you have two ways to map the memory. You can either map to image mem handle, which sort of what we call opaque memory or sort of device optimized memory, or just maps to USM memory. Device optimized memory is good because underneath it could be using any sort of device optimized format, such as the order layout. You don't actually know what that layout is, but it can make things more efficient on the device. With USM, it's you know the layout, just linear device layout, but might not be quite as optimized as using image mem handle. And then once you've imported those, you can create a sampled or unsampled image. When porting USM memory, you should also be able to use that just generally, although we don't currently test that. Here's what it looks like. First you create the memory in Vulkan, and then export memory from Vulkan, making it available for SYCL to import. You have to describe what kind of memory you've been importing currently. If you're supporting both Windows and Linux, you have to, depends on whether it's Windows or Linux. And three main steps is import memory into the SYCL context, map the memory to a SYCL object, and then finally create your image object. And it's roughly similar to code in DirectX 12. You create the memory, make it exportable. Then very similar here, describe what memory you've been imported, of course, for Windows only with DirectX 12. Import the memory into SYCL, create the image handle from the imported memory, and then you can create an image as usual, be it sampled or unsampled. And you can see here the process for both of these are very similar, only slight differences. The support for Linux on when using Vulkan Interop. Here's what the functions what they actually do in this case on the CUDA backend. So when you're calling import external memory, you're actually calling CU import external memory, putting it into the CUDA context. And then when you call map external image memory, it's actually quite interesting. You're calling CU external memory get mapped away, which you then have to get the first layer of. There is no other way in CUDA you always get it as a mapped array, which you can just select the first layer and then you're on your way. It's just how they designed it. And then map, and then with USM memory, it's just CU external memory get mapped buffer. What is currently untested at the moment on DirectX 12. Then of course you can create image. For unsampled images, you're getting a surf object internally, and with sampled images, it is a texture, CUDA texture. It works a bit differently for level 0. When importing external memory, you are creating a data structure which just stores, that is then used later on with map external image memory. Currently with level 0, we only support layout optimized memory, specifically only on Windows. And it's actually, when you're mapping the memory, it's actually already creating an image, a full image, which then when you use create image, it reinterprets that image via ZE image view create, which you can then sort of reinterpret the data either as an unsampled image or a sampled image. And the function that actually does the magic and makes it a bindless image is ZE image get device offset. Then with that handle, you can access it in a bindless way on the device. And once you are done, of course, you need to release the external memory object after using external memory in SYCL. On exporting memory from SYCL into Vulkan and DirectX 12, this is currently being investigated, and we hope to make the proposal public very soon. It's a different process than importing memory, and there are some some details that we are trying to work around to make it as flexible as possible. Now, on importing Vulkan and DirectX 12 semaphores into SYCL. Now, it's all nice and good having access to memory from Vulkan and DirectX 12, but to actually use it efficiently, you need to know when one's finished processing and when you can start processing it in SYCL or the other way around. So semaphores solve this synchronization primitives wait on a condition being met. The main caveat in order for semaphores to properly function is that the SYCL queue must be in order. Otherwise, the semaphore could be signaled before you've actually started running the kernel. Yes, like I said, otherwise the kernel and semaphore execution order is not guaranteed. We support two main types, what I call binary and timeline semaphores. Of course, with binary semaphores, it's just two-state signal unsignaled. Wait upon switch to the signal state. A lot simpler, but by their nature, they can increase complexity by being so simple that you just need a lot of them. These are supported by the enums OpenCL and Win32NT handle. Timeline semaphores, on the other hand, have a 64-bit integer value. They can be waited upon to be a particular value, and you can do that repeatedly. They are slightly more complex to use, but you can keep reusing the same semaphore, and they are a lot more flexible. This is supported by Win32NT DX12 fence, timeline FD, and timeline Win32NT handle. On the types of semaphores in SYCL, so the binary semaphores OpenCL and Win32NT handle are only supported when using interop with Vulkan. DirectX 12 does not, in fact, have any equivalent to binary semaphores. They only have an equivalent to Vulkan timeline semaphores. The naming terminology when it comes to semaphores, when you're comparing DirectX 12 and Vulkan, is quite confusing. Fences means two different things in each of them. So we just go with the naming binary and timeline semaphore. Timeline semaphores, of course, the DirectX 12 version is supported by Win32NT DX12 fence, and then of course you got the two timeline semaphores for Linux and one for Windows. And the basic process of using semaphores: get the semaphore, must mark it as exportable again, and then it's just a lot easier to import external semaphore. And then with the if the semaphore is created with the enum value at the top, OpenCL or Win32NT handle, you just pass a semaphore and it will signal that or wait upon that. But if you have one of the timeline semaphores or in DirectX 12 fence, you can pass an extra value to wait upon or signal using that value. It's what it looks like in practice. Abbreviated it a little bit to get rid of some of the Vulkan boilerplate. Create the exportable semaphore and export the semaphore from Vulkan, making it available for SYCL to import. We try to do sort of a similar sort of layout as it is to importing memory. Describe what kind of semaphore is being imported, and then import the semaphore from Vulkan into SYCL. And then is what it looks like in DirectX 12. Create the semaphore, export the semaphore from DirectX 12, and then describe what kind of semaphore is being imported, and then finally just import the semaphore into SYCL. And then, of course, similar to external memory, the external semaphore object must be destroyed after use. On exporting semaphores, neither CUDA or Level 0 has any capability to create the semaphores in them and export them. Their semaphore capabilities are really just to use semaphores created from Vulkan and DirectX 12. So we likely will not be able to offer something exporting semaphores from SYCL. Some problems encountered when mapping CUDA interop API is sometimes the legacy APIs pop up and are not that generic, making map difficult at times. In particular, when we had a little look at OpenGL, this requires using very, very OpenGL-specific CUDA API calls, which can be a bit difficult, make things a bit difficult to map at times. But at worst, if we needed to, we could make a separate SYCL station only applicable to CUDA and OpenCL interop. We have so currently all the SYCL interop with Bindless images is within the Bindless images extension. We are planning to spin them off as their own separate extensions, so that it will make it easier to add interop capabilities with non-Bindless images objects, which we will be looking at. For future work, we're going to be looking at, as I said before, exporting memory from SYCL into Vulkan and DirectX 12, splitting external memory SMFOS into their own extension. We are currently looking at DirectX 11 interop. There's apparently a lot of uses there with legacy video libraries there. We're also just doing general Bindless images improvements, additional image formats. We will likely be looking at SYCL buffer and definitely at least USM interop. Additional synchronization parameters as well, and likely also look at use imported objects with host tasks, so then you can directly access interop resources with the backend. Like such as passing a C array directly using to a CUDA function using a host task. Legal. Any questions?
Yes, well, people are thinking. I had a question. You say one of the limitations of this is around with in-order queues. How obviously you could use in-order queues and then stop your SYCL program so that you ensure that synchronization is possible. But how, given that Vulkan and DirectX and SYCL are all very asynchronous APIs in themselves, it's obviously a challenge. But how much appetite is there, and how difficult would it be to support out-of-order queues?
So it kind of goes into the CUDA streams, I believe. So I believe SYCL uses multiple CUDA streams. It can to do stuff asynchronously. I've not directly worked on that part itself, but it's maybe you could do something with like waiting for the queue to finish it in its entirety, then it could do the rest in order. I can't guarantee that that is feasible, but like we can't just add it to the internal CUDA object as it currently is, because it could attach to it to any CUDA stream, and you just don't know what's happening. But yeah, if we could do something like that, then that would be great.
You think it needs like being able to acute barriers and all that sort of stuff, so you could at least in theory know everything is done?
Maybe you obviously need some way to know when the queue's entirely done. I guess we were just doing it with the existing sort of functionality layout, where like you just add it to the queue and then it's X use out of order. No, this is an issue with semaphores. The easiest solution for us to get something working was definitely in order. But yeah, there could be slightly more sophisticated solutions to do that, to allow everything to be in order. But maybe certainly if the queue was deconstructed, that's an obvious signal, but do something a bit more elegant would be nice.
Do you find that applications needing the interop are using it out of order queues, or was it mainly just in order?
I don't know off the top of my head. Bindless images is just gaining support at the moment, because one of my main uses is with Blender. But yeah, we have some uses with interop. We're hoping to get more. We got a few people who are interested, which we'll see, and then we'll get feedback from them. We'll try to be very responsive to feedback.
So this Bindless from your side, is it purely a software feature or relies on some hardware features too?
From our perspective, it's purely software. It's just calling the already available CUDA or level 0 libraries, a few things were added for interop to work on level 0. No, we're not expecting any specific hardware features at the moment to get that working. There's already like a lot of support available an extent. I mean, in the end, it's all like memory on the GPU. The idea is just be able to reference this object within a different context, but you just need to know the layout and how to interpret it.
So versus the Bindless, performance-wise is similar to the one without Bindless support?
A good example of that is with the Blender people, their performance results. So Blender is using our Balancing extension. So we got, at least with the CUDA backend, very close results to the native CUDA backend in Blender that we were happy with Bindless images. Although Blender does not use any interop features at the moment.
Okay, thank you.
Okay, brilliant. Thank you.
Thank you.